Hello, my name is Amanda Woods, and thank you for listening and watching my talk today about unpacking innovative multi-team systems. Specifically, I will be presenting Meso-Theory of knowledge interdependencies and adaptability in multi-team systems. Many systems have been designed for the sole purpose of innovation to meet ever-present challenging needs in contemporary society. From health to spaceflight exploration to automation to education and the environment. Many industries have attempted to address the staggering need for innovation through developing entities dedicated solely to generating novel, useful, some might say innovative, solutions. Due to the complexity of emerging challenges and the need for large-scale innovation, organizations are often employing multiple teams that operate interdependently to generate solutions. We refer to these systems as multi-team systems, which are formally defined as two or more teams that interface directly and interdependently in response to environmental contingencies toward the accomplishment of collective goals. With this definition in mind, we conceptualize innovation multi-team systems as systems comprised of two or more teams that generate novel, useful solutions to complex challenges in conditions of high task uncertainty. Here we present the transformation cycle. Specifically, this model depicts innovation multi-team system functioning as we argue through our current theorizing. It encapsulates task uncertainty, multi-team system learning, system cognition, adaptive processes, and multi-team system performance. Now, due to time constraints, I won't be able to unpack all of the propositions that are associated with the interplay of these components, but I will highlight three novel contributions that highlight unique elements of innovation multi-team system functioning that we think will present value to the literature as well as practice. So the first notion is the notion of knowledge interdependencies. Knowledge-based interdependence informs component and between team actions in innovation multi-team systems. Taking a step back, much of the multi-team system literature has focused on action-oriented multi-team systems. Within this paradigm, this action-oriented paradigm, task interdependence has been sufficient in describing the coordination of these between team actions. However, in innovation MTSs, it's critical that these systems actually create, and they create under conditions of high task uncertainty. So with that in mind, it is the knowledge held by these component teams and the between team harmonization of these knowledge interdependencies that really drive the between team actions in more knowledge intensive multi-team systems, such as innovation multi-team systems. This feeds directly into an integrative mechanism that we contain within the transformation cycle of innovation multi-team system functioning, which we refer to as updating system cognition. This refers to an understanding of knowledge interdependencies at each level of the system that has been fully consolidated into the multi-team system such that it can be accessed by any level of the system. Referring specifically to updating, MTS learning events determining system demands are integrated into system cognition through mental models that converge through effective communication channels, discerning optimal alignment of component teams' efforts through the harmonization of knowledge interdependencies. So as we can see, the system is heavily reliant on this integrative mechanism to ensure that all of the component teams, that there is awareness of the knowledge held and the interdependent actions based on knowledge interdependencies that are occurring throughout the system. And this informs how the system is able to create and generate these novel, useful solutions. Specifically, we refer to this process as co-creation. This encapsulates or broadly encompasses creation that is made possible through harmonized knowledge interdependencies at the between team level, and the simultaneous creation occurring across the system that converges on either an optimal solution or induces another cycle iteration. So the purpose of these systems, again, to generate these novel, useful solutions, relies heavily on MTS learning events that then inform and shed light on new system demands, which then become integrated into system cognition. And this, along with past knowledge and current knowledge of between team actions, as well as the structure of knowledge interdependence throughout the system, are able to effectively inform the co-creation process that's required to continually generate these ideas that work towards optimal solution generation. And again, we synthesize these concepts into what we refer to as the transformation cycle. So here we can see the induction of task uncertainty creates an important condition for these components to operate within that induces system learning and acting as a learning trigger that then feeds into system cognition as well as into adaptive processes that reciprocally inform and update system cognition that is then leveraged and allows the system to continually co-create simultaneously, as well as to avoid the duplication of efforts that are occurring in this co-creation process throughout the system. This would either then again induce another cycle iteration and eventually lead to downstream performance. This allows for a scaffolded nature for co-creation to operate in, and that it can build off each cycle iteration every time, again, avoiding that duplication. Thank you so much for hearing about these unique aspects of innovation multi-team system functioning, the knowledge interdependencies that are harmonized and resonate throughout the entire system, as well as this updating of system cognition and the co-creation that really encapsulate how innovation multi-team systems are different from other multi-team systems, as well as how the unique challenges that they could face based on the processes that they rely on. Thank you.